Hi everyone, this is lesson 33 and we're talking about rounding numbers and estimating. This is really an appropriate strategy in math a lot of the times when you're trying to do quick mental math, or it applies to so many different things. It's funny though, I feel like one of the reasons I love math is because it's so concrete. I like definite answers. I like knowing that my answer is right, and my whole life, I've struggled with rounding and estimating because it's not so concrete. I'm curious if anyone else feels that way too. But without further ado, let's scroll down. Let's take a look at your learning targets for today. Um, we are going to use a number line to round a number to the nearest 10, use a number line to round a number to the nearest 100. Um, those are important strategies for me to review with you, for me to kind of show you, almost like just tools for you to have in your toolbox. Those specific strategies are not necessarily things that you need to know how to do in your future as a mathematician. They are simply strategies for you. So if you're looking at a number line, can you read a number line? Can you use that to help you? Like by looking at a number like 617. If you can imagine where that would be on a number line between 600 and 700, it helps you to visually see. So this maybe, for those who are more visual learners, visually see where that number falls and which side it would get pulled to, really. So not necessarily a need to use, but just a good tool for you to have in your math toolbox. And then rounding to estimate solutions to addition, subtraction, and multiplication problems. So oftentimes this is appropriate. It's appropriate for me to round. So the other day I was at the store and I was thinking about buying like some type of like treat for my students in class, like drink packets or something where we're not sharing out of the same package in this time of COVID and thinking about germs. But I'm trying to think of all of these individual little packages and about how many I would need. So all of my classes that come to me for math have different numbers of students in them. And as I was standing there in the store, I wasn't going to sit down and do the specific math of like 17 plus 19 plus, etc. So I rounded all of them. I knew all of my classes were right around 20. So instead of doing the specific math right there in the store, I just said, okay, I've got 4 math classes. Each of those classes has about 20 students. 20 times 4 is 80. I need 80 packages of snack or 80 packages of some type of a treat. Oftentimes, rounding just saves you a lot of time, and it's easier. It's more appropriate to do on the fly, especially. So this talks a little bit more about rounding and breaks that down a little bit more. It says when we use rounding, we do that when we do not need an exact answer. We can use a number line to help. I talked through this example right here, but people who are more visual, here's an example. If we're talking about the number 67, they put a box around the number 67 here, and we're looking at a number line. You can visually see that 67 falls closer to this number 70 than it does to the number 60. So if we were to round 67 to the nearest 10, and anytime they ask you to round, they'll tell you what they want you to round to. So to the nearest 10, meaning does it go towards 70 or does it go towards 60? In this case, 67 is closer to 70. It would round to 70. Here's another quick example. The attendance at a game was 614. We would say about 600 people attended the game. The price of shoes was $48.97. You'd say the shoes cost about 50 bucks, right? When a number is exactly halfway between two multiples of 10, we usually round it to the larger number. And that is something you've practiced. That's kind of wordy, but that's something that you've practiced ever since you practiced rounding from the get-go. 5 and greater, you round up, right? So 65 would round up to 70. 45 would round up to 50. 450 would round to 500. Anytime you're right at that 5, that halfway point, you round up, depending on where they're asking you to round to. Okay. Let's take a look at this first example. Round 523 to the nearest 100. In front of me, I have a number line. If you can do this in your head, do that in your head. If you're more of a visual person or you just want the extra practice, go ahead and do this on the number line. I would pause the video, but I don't necessarily think I need to. I can do this really quickly. So 523 is a number that's going to fall between what two numbers, what two hundreds? They're asking us to round it to the nearest, sorry, I need my pen, round it to the nearest hundred. That means that on either end of this number line, I have two different hundreds. I'm going to have 500 down here and then 600 over here. One common error as a math teacher that I might see is that people would put the 500 over here and 400 down here, or something around those lines. So make sure you're looking closely at what the number actually is and between which two hundreds or which two, whatever powers of 10 they're asking, it falls between. So we have 500 over here, 600 over here. Right directly in the middle would be what? It's important to kind of identify what the middle would be. That's kind of in the middle. That would be 550. And our number is not even that high. Our number is 523. I'd say maybe about here. Writing with a stylus pen is very difficult. Okay, so 523, I can visually see that it is closer here to the 500. It's rounded closer to 500. Example 2. This is very wordy. Okay, I'm going to read through this. I'm going to ask you to pause and solve, and then unpause your video when you're ready to check your work with mine. In a presidential election, each state is assigned a certain number of electoral votes. Based on the 2000 census, the state of Florida was assigned 27 electoral votes, and the state of Texas was assigned 34 electoral votes. About how many electoral votes can a candidate win altogether in those states? They're asking you to kind of estimate here. So, one important word, I know in third grade math, you talk a lot about keywords or important words in word problems or story problems. And this is one that should be like a buzzword or almost like send some type of alert off in your brain when you see it. About, right here, this word about. Whenever you are doing any type of story problem or word problem and you come across the word about, they're asking you to estimate. It's like the opposite of the word exact. Exactly how many votes? No, that's not what they're asking. About how many votes? So they're asking you to kind of estimate there. Pause this video, do your work, and unpause when you're ready to check. All right, so when I break this down, I started by looking at this number for Florida. 27, to me in my brain, 27 rounds up to 30. So I'm going to call that 30. And also this one right here, this number that's associated with Texas, 34. Again, that seems a little bit higher, but it's under the 5. 5 and above rounds up. It's under the 5, so even though it's higher, I'm going to round that also back down to 30. So they kind of balance each other out a little bit. So I end up with like about 30 plus about 30 and altogether 60. Good mathematicians don't leave their answer like that. I'm going to double check and see how I can label this. This is a word problem or story problem. It should always have some type of a label. So their final question was about how many electoral votes. I would say 60 votes. If I really wanted to be specific, I would say electoral votes. Oh my gosh, come on. Sorry about that. 60 votes. Here's another example. The average depth of the East China Sea is 620 feet. The average depth of the Yellow Sea is 121 feet. To the nearest 100 feet, we're rounding, to the nearest 100 feet, about how many feet deeper is the average depth of the East China Sea? Go ahead and pause this, solve, and unpause when you're ready to check your work. Okay, so a couple things I want to talk through here. Problems like this, it's kind of your preference. You can solve two different ways. You can estimate first or round first and then solve at the end, or you can do the math, solve, or you can do the math, solve the problem, and then round or estimate at the end. So completely up to you. I'll kind of talk you through both ways. If I were to just do this mentally by, as rounding first, I'm looking here, 620 feet and 121 feet. if I'm talking, and more specifically, it says to the nearest 100 feet. So already in my brain, I'm thinking about to the nearest 100. So 620 to the nearest 100 is 600, not over that 5. We're down to 600. And then same thing here, 121 feet would round down to 100 feet. So how many feet deeper? That's a subtraction problem. I would basically take 600 minus 100 and end up with about 500 feet. Was able to do that completely in my head. If you're more, I don't know, analytical, or if you really want to work it out, you shouldn't typically do this because this will take you more time. And in math, we're always looking for shortcuts. But just to show you specifically, if I do the work first and then round to the nearest 100, here's what happens. I took 620 feet and subtracted 121 feet. I got 499 feet. And from there, I rounded to 500 feet because they said round to the nearest 100. I bumped that up to 500 feet. Both gave me that same answer. One was much faster. One more example here. A community theater group is giving 4 performances of a play. The theater can seat 425 guests. There's a typo there, guests. All of the tickets for each performance have been sold. Estimate the total number of guests, again, who plan to see the performances by first rounding. Oh, it tells you specifically what to do. By first rounding the number of guests, again, 3-in-1 problem, for each performance to the nearest 100. So they're asking us to round first to the nearest 100. This is how many people can sit at each performance. This is how many fit into the theater. So 425. And there are 4 performances. Those are important numbers. So rounding first, if we round 425 to the nearest 100, that rounds down to 400. And there are 4 performances. 400 times 4 performances, well, 4 times 4 is 16. 400 times 4 would be 1,600. Our answer then would be, let's see, estimate the total number of guests. 1,600 guests. I'm just going to write that out. We estimated 400 per performance times 4 of those performances, and we got 1,600 guests. Hard to cross my T's with this stylus pen. Just some notes here for you to take a look at. Compatible numbers that are easy to compute mentally. So that's really what we're trying to do here. We're always trying to find shortcuts in our math or ways for us to solve mentally. Sometimes it's not necessary to round by multiples of 10. Look back at example 4 and round to 425 instead. So we do actually get a different answer if we rounded to 425. We're not going to go through and do that a second time. This is our last example. Okay, so Layla's car traveled 129 miles and used 4 gallons of gas. About how many miles did the car travel on each gallon? Okay, so a couple ways to solve this, right? We can do the actual math, 129 miles divided by 4. But a good mathematician would stop and do this. They'd stop and look at any patterns you might associate with these two numbers. We have 129 and we have 4. I know that I need to divide this or something around here by 4. And here's what I know about my multiples of 4. I know 4 can go into 12. 4 times 3 is 12. If I think about 12 in the sense of like this, where this is 129, that would mean 4 could go into not 12, but 4 could go into 120 evenly. If 4 can go into 12 evenly, 4 could go into 120 evenly. And if 4 can go into 12 3 times, that means 4 can go into 120 30 times. That would be a really close estimate on how many miles that car could travel on each gallon. So 4 gallons of gas, I would say So yeah, I would say, sorry, I had to stop and think for a second. 129 divided by 4, well, I know that 120 divided by 4 would be 30. That's going to be a really, really good estimate. I'm just going to write that out. I know 120 divided by 4 is an even 30. So I'm going to say 30 miles. That's a really good estimate.